Hi and Assalamualaikum. My name is Husna. I will explain for question 1 and question 2b. Question 1. Explain the meaning of differentiation and what are the techniques of differentiation. The meaning of differentiation is the mathematical process of finding the derivative of a function. It measures the exact rate at which a quantity changes at any given instant. Next, the techniques of differentiation. First one is derivatives of constant, linear, and power function. Second, derivatives of trigonometric, exponential, and logarithm function that consist product rule and quotient rule. Third one is chain rule, and the fourth one is implicit differentiation. For question 2b, find dy over dx for the following function. This is the question for 2b, and for this question, we will use the product rule. Formula for product rule is y prime equal to uv prime plus vu prime. So first, I will divide it by 2 and label it as u, and this one is v. For u, we have to differentiate 2 times. First one is ax square. Second one is x square. So for u prime, we got ex square 2x. Second one is v. We also have to differentiate 2 times, which is first one is sine x cubed plus 1, and second one is x cubed plus 1. And for v prime, we got cos x cubed plus 1, 3x square. Next, we will put all this into the product rule formula. So we got ex square cos x cubed plus 1, 3x square plus sine x cubed plus 1, ex square 2x. We also can simplify it as ex square 3x square cos x cubed plus 1 plus 2x sine x cubed plus 1. That's all from me.
Hi, I'm Elisha and I will be explaining the calculation for question 2a. So the question is, find dy dx for the following function. Y equal to ln 2x minus 5 over cos squared 3x. So firstly, we need to use logarithm law to separate this equation to get ln 2x minus 5 minus ln cos squared 3x. Before differentiate, we need to move this square in front of this equation so we can differentiate this equation easily. So from this, we can get negative 2 ln cos 3x. So we can differentiate this whole equation as usual. So we get 1 over 2x minus 5 to negative 2 1 over cos 3x minus sin 3x 3. So we need to simplify this equation and this equation. So we get 2 over 2x minus 5 and negative 3 sin 3x. So we simplify again to get 6. 6 we get from negative 2 and negative 3. And sin 3x over cos 3x we get from 1 over cos 3x times with sin 3x. So if you notice here, sin 3x over cos 3x have the same value of degree. So we can use trigonometric identities to get the simplest answer. So the final answer will be dy over dx equal to 2 over 2x minus 5 plus 6 tangent 3x.
Assalamualaikum. My name is Najah Sofia, and today I'm going to show you how to solve this calculus question. Our equation is xy plus 3x squared equals to 2 cos of x plus y minus e to the power of 2y, and we want to find dy over dx by using implicit differentiation because x and y are multiplied together. And then, if we take the derivative of y, we will put dy over dx right next to it. And let's look at the left side, xy plus 3x squared, and for xy, we will solve it by using the product rule. U equals to x, and u prime equals to 1. We get it by differentiate the x, and v equals to y, and v prime equals to 1 over dy over dx by differentiate the dy. And we will get x dy over dx plus y, and we will put it on the equation. And next, we will differentiate the 3x squared. 2 times 3, 2 minus 1, and we get 6x. And then for the right side, 2 cos of x plus y and minus e to the power of 2y, we will use the chain rule. And for the cos term, we will get minus sign, and it will be minus 2 sine of x plus y times 1 plus dy over ds. And for the e to the power of 2y, we will get e to the power of 2y, and we differentiate the 2y, and we will get 2 dy over dx. And then we open the bracket and we get this equation. And then we will group all the dy over dx to the left side. And then we will move everything else to the right side. And for we pull the dy over dx out as a common factor on the left, and we put it here by dividing it, and we will get the final answer. Dy over dx equals to minus 6x plus y plus 2 sine of x plus y over x plus 2 sine of x plus y minus 2e to the power of 2y. That's all for me. Thank you.
Hi, my name is Nuri. I'm going to explain the question 4. Today we are going to use differentials to estimate the value of square root 9.03 plus 1 over square root 9.03 correct to 3 decimal places. Step 1. Define the function and variables. First, let's define our function and identify our variables. Based on the expression, we can write the function as fx is equal to square root x plus 1 over square root x. To make differentiation easier, we can rewrite this index form as fx is equal to x to the power of 1 over 2 plus x to the power of negative 1 over 2. Next, we choose a perfect square value close to 9.03 as our x node. So let's set the x node is 9 and the x is 9.03. Step 2, find the x and differentiate the function. Moving on to step 2, we need to find the small change in x, which is dx. By subtracting x node from x, we get dx is equal to 9.03 minus 9 equal to 0.03. Now, let's differentiate our function fx to find f prime x using the power rule we get. F prime x is equal to 1 over x to the power of negative 1 over 2 minus 1 over 2 x to the power of negative 3 over 2. Step 3. Apply the approximation formula. Now we apply the linear approximation formula. F in the bracket x naught plus dx is equal to fx naught plus f prime x naught times with dx. Let's substitute our function and its derivative into the formula. This expression is in the bracket square root x naught plus 1 over square root x naught plus 1 over, in the bracket 1 over 2 x naught to the power of negative 1 over 2 minus 1 over 2x to the power of negative 3 over 2. Multiply it with 0.03, which is the dx. Next, after we substitute the x naught, which is 9, we get square root 9 plus 1 over square root 9 plus, in the bracket, 1 over 2 times with 9 to the power of negative 1 over 2 minus 1 over 2 times with 9 to the power of negative 3 over 2 in the bracket 0.03. So after the calculation, we have the answer is 10 over 3 plus 4 over 27 times with 0.03. When we calculate the final value and round it off to 3 decimal places, we get 3.338. And that is how we use differentials for estimation. Thank you for watching.
I just had to let you know you're